Okay, last one of the day. And then, yeah, and then you can have beers, right? And I can fly home. Hopefully. Okay. So, recap. So this morning, Adrian told you about, it gave you the big picture, different layers of services. You saw all the high-level stuff, very cool. But sometimes you need to train on your own data and solve custom problems. And so you can take it down one level, work with a service like Sagemaker that I will talk about now. And on Sagemaker, we'll be able to train different machine learning models and deep learning models and do all kinds of custom stuff, just like the ones you saw in the previous talk, okay? But what Sagemaker really does is trying to let you focus on the machine learning part, right? So far, I've trained on very simple data sets with simple models. I could do all of this on a single server, fine, right? There wasn't too much work involved when it came to infrastructure and DevOps, etc. Okay? Now, let's imagine you have to scale this, right? And you could scale it in 2 dimensions. You could say, well, now I need to train on 10 terabytes of data. Okay, so I will need a lot of storage. I will need a lot of computing power. And man, probably I will need to build clusters. And okay, here comes DevOps, right? So that's one dimension. The other one is I'm just playing with simple examples here by myself, but now I want to give a sandbox to the 50 developers or the 50 data scientists in my company. So each one of those persons wants training servers, prediction servers, storage, etc., etc. They want to be autonomous. They don't want to create tickets. And anyway, I don't want to be in charge of handling those tickets. So here comes DevOps again. Okay, so it doesn't matter if you need to scale data and models, or if you need to scale just from a team perspective. You will always end up in that dark space where things started out as a machine learning project, and they end up with managing infrastructure, automating servers, blah 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 blah. Right? So quite a ripoff. So let's look at the typical machine learning process and see what the pain points really are and how Sagemaker can solve them. So it does start with problem discovery, right? Figuring out what's the question you want to answer. And that sounds like a silly thing to say, but a lot of people actually rush into machine learning without a proper question to answer, right? It sounds like a Dilbert cartoon. It's like, we need a machine learning strategy, right? Just like 10 years ago, we needed a big data strategy. What for? Well, we need one for sure. Okay. All right. Thanks, boss. Okay. So whoever comes to your desk on Monday morning and taps on the shoulder and says, we need a machine learning strategy, just tell them, okay, we'll figure out the strategy. Just tell me what problems you want solved. Okay. And these should be simple questions. Okay. These should be simple questions. We want to predict customer churn. We want to classify images of mechanical parts. We want to detect cancer on medical images. We want to blah, 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 blah. Okay, these are real life problems, and maybe they can be solved with machine learning. Okay? So once you're on your way to answering the question, usually the first thing you need to do is figuring out what data is required to answer the question. Okay? And usually this means talking to domain experts, understanding how people would do it, because if you don't understand how people would do it, how could you come up with a solution for machines to do it, right? AI and machine learning are dumb as hell, right? They just do what they're told, pretty much. They're only as clever as the data you throw at them. So you need to have the right data. And so you need to collect this data, you need to integrate it, you need to merge and clean and aggregate everything into a repository that you will use to train your models. So if you're using AWS already, well, the good news is we have plenty of data and big data services to do this. Okay, so when it comes to cleaning data with Glue or ETL, or when it comes to aggregating data with EMR or Redshift or something else, then fine, right? And of course, S3 is where you'll store everything, and S3 has no limits. So when it comes to having storage, you'll be fine here. Okay, so these tools are available. Okay, fine. So now you have data, and you aggregated it and cleaned it and normalized it, etc. And now you can start on the proper machine learning task, which is understanding the data, visualizing it, looking for correlations and statistics, doing feature engineering, starting to train your first models, measuring performance, etc., etc. Okay, and this is where also the problem starts when it comes to infrastructure. Okay, because if you're doing this in the development environment, well, you do need a development environment, right? If you're doing this in production with big data sets, well, you need infrastructure too. So actually, a lot of time will be spent, like I said, building training clusters, managing storage, managing distributed training, etc., etc., and building this for as many people as you have in the team. Okay, so someone will have to do that. And it's not machine learning, so that person won't be happy, I guess. So then, once you have a working model, it just gets worse because you need to deploy the model in production. And once you're in production, then you need to worry about silly things like availability, especially if you plug this into web apps and mobile apps. You need to worry about load balancing, scaling, monitoring, right? A number of things that have pretty much nothing to do with machine learning, but of course they're important for the overall performance of your app and your product. Okay, so once again, a lot of time will be spent doing DevOps work and infrastructure work to deploy the models. And this is actually, I believe, more work than this part, right? If some of you have actually taken models to production for web apps, this becomes a nightmare pretty quickly, especially if you have a very nice Python model or R model, which worked, of course, very, very well in the dev environment because you were probably hitting it at 1 hit per second or 1 hit per hour, right? And then you take that Python code, put it in production, hit it at maybe 1,000 hits per second, and oh my God, it doesn't scale. What do we do now? So that's a problem, okay? So these things are pretty much what Sagemaker is trying to solve, okay? Sagemaker is trying to let you run that overall process, but without the infrastructure drama, okay? So you can go from experimentation to training, to hosting, to deploying, to A/B testing models, etc., etc., with the same SDK, the same tools, the same service. Okay, so you don't have to use 5 different things to get the job done. And we'll talk about the Sagemaker SDK, and of course, I'll show you some demos. When it comes to infrastructure, there is 0 setup. Okay, and when I mean 0, it's absolutely 0. So you never manage a single server. You could be doing distributed training on 100 servers. You could be building prediction clusters of 100 servers. The only thing that you will say is, okay, please deploy 100 servers, right? That's it. You will never manage one of those servers. They're fully handled by Sagemaker. When it comes to training, you have a lot of choice. You can use built-in algorithms that come in Sagemaker. We'll show you the list. And you'll find the usual stuff, linear regression, clustering, classification, PCA, etc., etc., and some more advanced algos for time series and natural language processing, etc. And some of those algos have actually been invented by Amazon and published by Amazon. And so you can use those off the shelf. You don't have to write an algo. You can just use those. If you want to use TensorFlow, MXNet, Gluon, scikit-learn, PyTorch, etc., we have environments for that. Okay, so it's very easy, as you will see. You will never have to install TensorFlow again, or MXNet. Right? Just not picking on TensorFlow specifically. And you pay for all of this by the second, just like for EC2. So you will pay for the training instances, but they're starting and stopping automatically, so you never pay for stuff you don't use, and you pay for prediction instances. So let's look at the end-to-end cycle. So actually, to make it really convenient to manage dev and test environments, you can use notebook instances. This is what I've been using for the previous talks. So these are fully managed EC2 instances, pre-installed with Jupyter and the libraries that I mentioned earlier. Okay, again, that's what I use all day long today. If you don't want to use those, fine. You don't have to. You could use your own Jupyter environment, or you could even use your own Python scripts. That's fine too. As long as you use the SageMaker SDK, you can just get things going, right? So you can pick from the built-in algos, you can pick from the pre-built environments. It's one click or one API call to get the training show going. Another extra feature, it's in preview right now, but you can join it. It's called HPO, Hyperparameter Optimization. And this is actually applying machine learning to predict, to help you figure out what the right, and I don't want to say optimal, but you know, what better hyperparameters you could use for your training jobs. Okay, so remember this, this morning we talked about the learning rate and the batch size and the number of epochs, and you could have other hyperparameters for your algo. And it's not easy to figure out what the right value could be. Okay, so here by using HPO, you can say, okay, please figure out an optimal learning rate between 0.1 and 0.00001, okay, and create 20 training jobs. So SageMaker is going to fire up 20 training jobs in parallel, and look at the results, and applying machine learning to those results. It will say, okay, this value is what I think. I think this value is the optimal one. Okay, so machine learning to predict parameters. Pretty cool. And then once you have a working model, again, one API call, and you deploy it to an arbitrary number of web servers to serve predictions. Okay? And these, again, are fully managed. So let's look under the hood. So all this stuff is actually Docker-based. Okay? So don't worry, you don't need to know much about Docker, and this is not the container track. Right? You just need to know a little bit about Docker if you want to use your own container, but we'll get to that in a minute. So in ECR, which is our Docker repository inside of AWS, we have already pushed pre-built images, pre-built containers for the built-in algos, the TensorFlow environment, the MXNet environment, etc., etc. Okay, and these contain everything pre-installed for you. So when you want to start training on SageMaker, you actually write just a little bit of code using the SageMaker SDK, okay, in Python. We call this helper code. And so basically what the helper code will do is select the right container. And let's say you want to do a TensorFlow training. So you say, okay, I want to use the TensorFlow container. And this is how many instances I want. And these are the parameters. And this is my training script. Okay, a few things. And you will run this. And this will fire up as many training instances as required. It will pull that TensorFlow container to those instances, inject your parameters, point that code at the training data in S3 and train. Okay? So you wait for a bit. Once training is complete, the model is saved in S3 again. Okay? And those instances shut down. Okay, so you stop paying. Again, you never overpay for training in SageMaker by design. And if you want to deploy that model, then again, you will write a bit of helper code saying, please deploy this model to X instances. And you run that, and again, it will create those X instances, pull the TensorFlow container to those instances, load your model, and build a web app and start serving predictions through an HTTP endpoint. Okay? So that's the way it works. So again, unless you want to build your own custom thing for training, because maybe you have your super secret proprietary C++ library for prediction, right? Why not? Unless you want to do that, you really have to know nothing about Docker, which is good because you didn't go to the containers track, right? And you were right. You were right. Although it's a great track, too. Anyway, a few more things. So these are more recent features. So one of the problems with this, right, is that people said, well, that's OK, but I don't always want to run my stuff on SageMaker, right? Maybe I want to train locally. Maybe I have my own dev environments, and they're fine, and they're running. And I just want to use SageMaker to train at scale, right? On a daily basis, I don't want to use it. I don't want to pay for it. Okay? It's a fair comment. So literally a week ago or something, we open sourced the containers for TensorFlow and MXNet. So now you can go and grab them on GitHub, okay, and build them, and build the exact same containers that we use on SageMaker. Of course, you can customize them if you want to add your own TensorFlow tools or some dependencies, etc. That's fine. You can run them locally for development and testing, okay? And you could push them again to SageMaker to train and predict at scale, right? So this is pretty cool, I think. This is a much expected feature. And if you want to bring your own container, and time permitting, I'll show you one of those SageMaker examples with R, maybe, at the end of the talk. There's also another repo called SageMaker Container Support that helps you build your own container. So if you want to bring your R code or your C++ code or your something else code to SageMaker, it's possible. Okay? And so we simplify integration between SageMaker and your container, right? Providing entry points, providing easy ways to pass parameters to your container, providing you with an Nginx-based HTTP server to serve predictions, etc., etc. So that basically you only have to bring your machine learning code inside that container and nothing else. Okay? All right, we'll look at those later. So, demos. Yeah. How many slides can you guys take in a day? How many can I take in a day? All right. So, just want to show you quickly what I'm going to be using now. Okay, so actually most of the examples that I'm going to use are on GitHub, on the official GitHub, and some of them are mine, but they're on GitHub as well. And so SageMaker examples. So all of these are notebooks showing you how to use SageMaker in many different ways and how to use the SDK. They're also pre-installed on notebook instances. So this is the fascinating SageMaker console, right? One of the better looking ones, I believe. You can join HPO here, as you can see. And you can create a notebook instance, which I already did. And you can see your training jobs, and you can see models that are hosted, and you can see endpoints, so models that are live and serving predictions. Okay? That's about it, right? But it's good. We don't care about the console. Let's jump to the notebooks. So let's look at a simple one first. And let's start with built-in algos. So that's this introduction to Amazon algorithm. So the list of built-in algos. I think we have 12 now. Okay, here they are. Okay, so you can see the usual stuff, right? Like I said, linear learner, which you can use in regression or classification mode. Oh yeah, factorization machines, XGBoost for classification. There's an image classification algo which is based on deep learning. Okay, so if you want to do similar examples, as the one in the previous session. You can do that very easily. Sec to sec is it's an LSTM architecture. It's what Sockeye uses for translation and what Amazon Translate uses too. K-means for clustering, PCA to reduce dimensions. LDA and NTM are, again, topic modeling algos, and this is actually Comprehend uses LDA. DeepAR is a time series. It's a new one. It was added after launch. This is Amazon invented. Blazing text is natural language processing. It will compute word embeddings, which is something that you pretty much need to do every time you do NLP. And you may know of a Facebook algo called fast text, okay, which was, I guess, the state of the art. But fast text only runs on CPU, and blazing text, I believe, is actually the first GPU implementation of this thing. So much faster. So here's the list, and I'm guessing we will add more stuff. So how do you work with those? Let's try a simple one. Let's continue on our MNIST obsession. So here we're going to use the linear learner. And we're going to use it in classification mode, okay, in binary classification mode. And what we want to do here is predict if an MNIST digit is a 0 or something else. Okay, so remember those MNIST samples? They are 28 by 28 pixel large. So that's 784 dimensions. Okay, so we're trying to find a linear split in that 784 dimensional space with the zeros on one side and everything else on the other side. And again, if you can see this in your head, take me with you to your planet, okay? Because I guess I'm tired of Earth. Okay, so this is what we're trying to do. So it sounds like a completely weird idea, right? But why not? Why not? So how do you work with SageMaker now? So the only thing that you need, pretty much, is an S3 bucket. Okay, because as you saw from those previous slides, data is in S3, and the model that you train is saved in S3. So all those scripts, right, if you look at the GitHub scripts, somewhere over there, right, all of them will say your bucket, okay? And before you ping me on Twitter saying, I can't access your bucket, yeah, because it should really be your bucket, right? Believe it or not, somebody asked me the question once. Just saying, right? You can always delete the tweets later. That's okay. No one actually notices but me, and I'm a very nice person. Okay, so you need an S3 bucket. You need a role which you can grab directly from the SageMaker session, because, of course, SageMaker will write and read to S3, needs permission to do that. Then, of course, we're going to download MNIST for the millionth time. We could inspect the data set. Why not? Okay. This is a 3, if you say so. Yeah, I thought my digits were ugly, but this is actually, I should use that one. And this is more important, data conversion. So the built-in algos require that you provide training data in a specific format. So of course, we all read the documentation, right? And so if we read the documentation, we see that the linear learner supports protobuf and CSV. Okay, so we should format that data set as protobuf or CSV. Okay, so please read the documentation. So I'm going to do that. So I'm going to take those images. I'm going to flatten them to vectors, and I'm going to write those samples with the labels as a protobuf file. Okay, and I can use it. I can do it using this function in the SageMaker SDK. Okay, just data manipulation. So actually, a reason why all of these SageMaker notebooks are very, very nice, I think, is because they provide you with all those snippets that you can really reuse anywhere, right? So anytime you want to transform data to protobuf or JSON or something else, it's quite likely that one of those sample notebooks shows you how to do this. Okay, so spend some time reading them and memorize or keep all those snippets somewhere, because you will reuse them, okay? Trying to figure out from scratch how to do this is a little bit more complex. Okay, so I wrote my data set in protobuf form. I want to upload it to S3, okay? That's easy enough. I can just use Boto to do that, okay, here. Upload file obj, okay, fine. Okay, so now my data is in S3, it has the right format, and I just want to run that linear learner on it. So like I said, this is Docker-based, right? So here we go, yeah. This is Docker-based. So ECR is a region service. So there will be one linear learner container in each of the regions where Sagemakers is available. So here I'm running in US East, but that's okay because I can automatically figure out in which region I am, right? So that my notebook is actually generic, okay? So try not to hard code region names in there. So how should I train actually? So I'm gonna use this estimator object that takes a few parameters. So the actual container, so the linear learner container for the region I'm running in, the role, the session, the output location, right? And of course, importantly, those two things. How much infrastructure do I need to train, right? And when I said 0 setup, that's what I meant, okay? This is all it takes. You just say, okay, instance count is this, instance type is this, you manage it, right? You will never get to touch those instances, which is fine, as far as I'm concerned. Okay, and then I need to set some hyperparameters. So how many dimensions do I live in? So 784. And I'm trying to find that hyperplane, splitting that in two. A binary classifier is what I want, okay? This algo can also work in a linear regression mode if you want to predict house prices in Munich. Okay, that works too. And then I can just train called fit on my training data. And that's all it takes. Okay? And then, of course, it's going to fire up that C4 Excel instance, pull the container to it, inject the parameters, and off we go, right? And so it trains for a while. So the training log is also available in CloudWatch logs. Okay, so you don't have to run this from a notebook. It could run automatically from a script, and you would get your log in CloudWatch logs. Okay? And after a while, it should say job complete. And I see some metrics. And, well, we don't care so much for now. Okay, so let's say I'm very happy with the performance of this model, and now I just want to deploy it and serve predictions. Okay, and this is where usually it gets weird, because the data science team would do the above. They would save the model somewhere and throw it over the wall to the development team. Say, guys, right now you need to integrate this model in the web app. Okay, and you don't quite know what the model does, but okay, you do it. And then you take that bigger thing and you throw it over the wall to the ops team for deployment. And they really have no clue what's in there, and they have no clue how this thing works. And they have no clue whether it performs or not, right? And then your life becomes interesting, and you start working on weekends. Yeah. So we think this is not the right way to do it. So we think the right way to do it is just to call the deploy API on the model you just trained, saying, well, please deploy this to one instance M4XL, right? And you have other options if you want, for example, for a test environment, you want a very, very inexpensive instance. Of course, you could use T2 to do that and save even more money, okay? So you wait for a bit, and then your model is ready to use, okay? And that's all it takes. If you wanted to deploy to 50 servers, you would just say 50 here, and that's the only difference, okay? It creates an endpoint and starts serving HTTP predictions. Okay, which we can do like this. All right, we could just call the predict API on the endpoint that we just created. Okay, so we need to worry about data formats. Reading the documentation, we would see that linear learner takes CSV and again protobuf as input formats, I think. So we can serialize and deserialize as well, provide some helper functions. And we can run some predictions here. Okay, and of course you could take the HTTP, the actual HTTP endpoint for the model, and invoke it with your SDK or using your favorite HTTP library. Okay, and that's all it takes. So as you can see, we just work with the Sagemaker SDK, basically prepare data, convert it to a format that the algo understands, define the training job just like this, train, and then deploy with a single API call and start serving predictions. Okay, that's the simplest way you could do this. Okay, now let's say, how are we doing on time? Yeah, let's say you don't want to use one of the built-in algos, okay? Let's say you want to use Tensorflow, why not? So how would you train with Tensorflow on this thing? And we'll do MXNet too, so that no one's jealous. Okay, so here, this is how you would do distributed training on TensorFlow using SageMaker. Okay. Okay, so it starts the same, import all that stuff, download the MNIST dataset, blah blah blah. You would do this in exactly the same way if you wanted to use it with TensorFlow on your local machine. Upload MNIST to S3, fine. Okay. Now you need your TensorFlow script, right? And this is something that maybe you worked on your local machine, and you just now need to train at scale. You want to train this on much bigger data set, or you need to automate it, whatever. So you would take your exact same code. Okay, there's nothing. If you're familiar with TensorFlow here, you can see the convolution layers, and this looks like LeNet, I guess, a little bit. Okay. And the only thing that you need to add is basically, if you want to serve predictions with this, you need to add a simple function that will actually perform the prediction. Okay, you need like a standard entry point for SageMaker to call. Okay, but nothing bad. Okay, so it's really vanilla code. And how do you train actually? Well, this is pretty cool. You just create the TensorFlow object from the Sagemaker SDK. You pass the script as a parameter. Okay, your own script, the one that we just saw, and you just say, well, please train on 2 C4XL instances, and that's it, right? And again, I would encourage you to try and do this outside of SageMaker, right? Try to do this with local machines or EC2 instances. Try to set up MXNet distributed training. Try to set up TensorFlow distributed training. Okay, see how long it takes before you can actually run. It's not going to take days, but it's a bit of work, especially when you want to automate it. If you want to do it like one shot, fine, right? You can hack your way through it, like I do. But if you need to do this 100 times a day for multiple teams, right? This is a lot of work. So you need to automate it, and problems start showing up. So here, that's all it takes. And you call fit, and then you can just see the training log. And it looks like we have very, very creative developers because we have different colors for the different instances, right? So very nice, artistic, right? Love this. Okay. The next step would be ASCII art, I think. So I'm going to create a feature request for that. Saying job complete in ASCII art. That would be great. And of course, to deploy, you just do the same thing. Okay, one M4XL instance. Wait for a bit, and then you can start serving predictions. Okay, and again, calling that predict API here, and making sure our data is in the right format. Blah 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 blah. We can predict accurately the digits from MNIST. Okay. So of course, MNIST is tiny. It's a waste of time and money to do distributed training on this. But imagine you need to work on terabyte scale data sets. I mean, ImageNet is 150 gigabytes, and it takes forever if you need to train on a single instance. So the only thing that would be different here is just say, okay, give me 10 instances, and that's fine. Okay, and you don't need to worry about it. Okay, and if you're a machine learning engineer or if you're a data scientist, you're fully autonomous here, right? You don't need to rely on anybody in the DevOps team or in the infrastructure team to give you servers, blah, blah, blah. You can just grab servers, release them when you're done, and that's fine. Okay, so I see this as a huge time saver. So how would you do this in MXNet? So let's look at this example here, and then we can take a look at Gluon as well. Quick look. So here I'm going to do oh no, I don't want to do this one. I want to do the sentiment analysis one. Yeah, this one. Okay. So here's the same story, right? I've got my MXNet script, and I want to do training on SageMaker. Okay, so I'm using a data set for movie reviews, positive and negative reviews, and I just want to build a sentiment analysis model. So downloading the data, copying the data to S3, same old, same old. Here's my sentiment analysis script, and this one is using Gluon. So I'll just go really, really, really quick because we don't have time for this. I just want to show you the difference here. Okay, remember what I said in the MXNet session. Said when you work with the symbolic API, you stack up those layers, you build a model, you train, and then hopefully you get a good result. Okay, and we don't have any control on the training loop. Just called fit, and whatever happens, happens. When you work with Gluon, okay, you still build the model using, of course, APIs. And they're somewhere down there. Yep, see, okay. And then dense, these are fully connected layers, and embeddings are a different symbol to build word embeddings, etc. Okay, so you would see your convolution objects and everything else. Just works the same. But when it comes to the training loop, we can actually see it here. If I zoom out a bit, no, can't extend this, unfortunately. Okay, I see I'm iterating over epochs, okay? And I'm iterating over each batch, and then I can specifically forward each batch into the model, and I can update my metrics. So if I needed custom metrics, different from validation accuracy or something, I could do this. And I can control backward propagation, blah, 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 blah. Okay, so here's forward propagation actually, computing the loss, taking the backward propagation, and then running gradient descent optimizing. So I can control each of those steps very finely, and I could have the Python debugger in there, break into breakpoints and step, etc. Okay, so it looks like more work, but actually this training loop is very generic. You can you reuse it as is with your own data, etc. And this behaves exactly as code. So you have full visibility over the training process. Okay, closing this Gluon discussion. So I've got my script, and just like we did for Tensorflow, we can grab that MXNet high-level object, pass the script, pass some hyperparameters, okay? And this is so hyperparameters that are passed to your training script, okay? And here I'm saying, okay, I want to run this training job on 4 C4 2XL instances. Okay, fire that up. Okay, again, training log. Nice colors again. Very nice, creative. And then I can deploy, okay, on one instance, and then I can predict, right? And I can check out some predictions here, make sure my sentiment analysis thing is working. Okay? So this is it pretty much, right? Again, try to do this or read the tutorial to do this manually, and then probably your conclusion will be, well, SageMaker looks like a better option. Okay, because it's really, really super easy to focus on the machine learning task and just ignore the infrastructure task. Okay? Just ignore servers. You need them, yes, but you don't want to see them. So let SageMaker run them. Okay? So, yeah, final example. how do you bring your own container? So now we go to advanced functionality. Ooh. And, well, I made fun of R a bit, so I should show the R example. So now, this is when you don't want to use the built-in algos, you don't want to use the TensorFlow or the MXNet environments. You just want to do your own thing. Okay, so now you understand how this works. We need a container for training, and we need a container for predictions. So in this case, if we want to build our own, to bring our own library, well, we need to build our container. And this is the bit where you do need to know a little bit about Docker. Okay, but it's not that bad, I think. So here, you just need, of course, an S3 bucket again. You will need to bring your R code, okay? But it could be C++, it could be anything, okay? So you need to bring your own code, a training function. So close your eyes because it's R code. It could be scary. Yep. So training code for training, R code for training, R code for to serve predictions, okay? And again, this could be anything else. Or this could be, like I said before, it could be your custom version of the TensorFlow container or your custom version of the MXNet container. So we need to build a Docker container, so we need a Docker file. Okay, so if you've never seen Docker before, a Docker file is basically, it's a document that contains commands, Docker commands, that let you build a Docker container. So it's not a script, right? It's not something you will run. You will just pass this to Docker, and Docker knows how to do with it, okay? So we're starting from an Ubuntu 16 base image, because of course we don't want to install everything. We're going to run these commands inside the container. So we want to install the R binaries, etc. We're going to install some more packages. And of course we're going to copy our training and prediction scripts from the local machine into the container, okay? And we're going to define the entry point, which is what SageMaker will call inside of your container. Okay, so as you can see, it's not very complicated. There's another example for scikit-learn. So, of course, scikit-learn is Python, so you could use the vanilla Python container to do it, but they just show you how to build, I guess, a more complex container. More complex custom container. Okay, so now we have a container. So of course you would need to test this locally and make sure it works the way you want, because once you push it to SageMaker, it becomes a little more complicated to debug. So work locally, make sure everything works the way it should. And then, oh my God. Here's my contribution to SageMaker. Okay. Should send a pull request for this, right? To make even more friends. Anyway, so once I've got my container, I need to push it to ECR, okay? So just in case I don't have a repository in ECR, I can create it. And this is another of those code snippets that are really useful. It's completely generic, right? Just change the algo name here. But you can reuse this thing as is. So, and maybe the region name if you want to change it to. Anyway, so here you will build a full container image. Oh no, is that the repository? No, it's the container image. Okay, so you will create a repository with that algo name, right? If it doesn't exist already, you will log into ECR, and then of course you're going to build the Docker image. Right, you're going to tag it with that full name, and you're going to push it. And these are, of course, standard Docker commands. And that's about it, right? That's about it when it comes to Docker. You don't need to know more. Just need to know how to build an image that complies with the SageMaker naming conventions, etc., etc. There's a bit of documentation to read, but it's not really, really complex. And you just build it, push it, and that's it. And from now on, SageMaker can just use it in the exact same way as we saw before. So you just go and grab this container, create the trading job, blah, 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 blah. Okay, then it's all the same. Okay? So that's the only time where you need to know anything about Docker. And I guess it's not so much, right? Okay, what did I forget? I think we saw pretty much what I wanted to show you. Yes. Yeah, built-in algo. Yeah, there's one thing I didn't show you, but yeah, we can. You can. This is left as an exercise to the reader, as we say. But it's worth talking about for a minute. So let me put that SageMaker slide again. This one. So I show this as a circle, but as you can see, you could really enter and exit at any point, right? So you're not locked in. So you don't have to go through every single thing. If you don't like the notebook instances, don't use them, right? If you want to train on SageMaker and deploy elsewhere, you can do that. You can train, grab the model in S3 and deploy it elsewhere, right? That Tensorflow model or that MXNet model, these are perfectly normal models. So you can grab them from S3, run them locally on your machine, deploy them on your own servers if you want, okay? If you want to import an existing model, so let's say you already trained a model and you're very happy with it, you don't want to retrain, you could import that model here, right? Host it in SageMaker, and you would sit in the console and everything, and you could then just deploy it using the SageMaker SDK. Okay, so you should really see these as modules that you can use according to the problems you're trying to solve. Okay, but again, if you want to go the full circle, as you can see, it's very tightly integrated. It's easy to work with other AWS services. Of course, you can use the Boto 3 SDK in your notebooks. If you need to pull in some data from RDS or Redshift and build all of it and clean all of it on the notebook instance, it's fairly easy to do. Now we have pretty large things here. We have the big C5s and the big P3s available as notebook instances. So you can actually do a lot of heavy duty work on those now. Okay, but again, just pick what you like. And just simplify your machine learning process and solve your specific pain points, right? Okay, so as you can see, end-to-end, right, if you want to. Zero setup, you will never manage another training or prediction server again, right? I forgot to say one thing. We have auto-scaling now. It's a fairly recent feature for the prediction infrastructure, right? So let me go back. That's important. No? Yeah, should click here. Okay, here. Okay, so those prediction servers, you can auto-scale them like you would auto-scale EC2 actually. Okay, so you define metrics and you can auto-scale that as well. So that's one less thing to worry about. Okay. You can train with built-in algos, which are Amazon implementations. So you can expect them to scale. You can train with built-in environments for MXNet, Python, TensorFlow, etc. Okay, or you can bring your own thing, as long as again you provide entry points to SageMaker, etc. You can build your own container and push it and run it on SageMaker, and you pay by the second for everything. And specifically for training, I think it's very efficient because it starts and stops automatically. So you never pay for stuff that you're not using, which tends to be a problem with large clusters because they're a pain to set up and no one wants to tear them down. So, right, like Hadoop, we build them and they run 24/7 for 5 years, even where they're not really busy. So here, none of that. All right, so some more links. So you've seen those before, right? That's the top level page for SageMaker. That's including customer stories, which I didn't cover today. The SageMaker notebooks, okay, the examples. The SDK is also open source if you want to take a look at it, and of course you have documentation there. If you want to see more examples on using SageMaker, I recorded a YouTube video that seems to be quite popular, and I'm showing you the different use cases. So using a built-in algo, I think the XJBoost example is in there. So bring your own script. bring your own model. I think I went through that one. So taking an external model and deploying it on SageMaker, building your own container, etc. So if you want just more examples, this is a good one to watch. And of course, my blog where you will find more SageMaker examples. There's a time series examples, example using DeepAR for temperature prediction, and there's a factorization machine example to build a movie recommender, and some other stuff, right? Okay, well, that's the end of a very long day. So, of course, we've got more time for questions if you want to, but if you want to run away and have beers, I will understand that. So, thank you so much for coming to this event today on behalf of all my colleagues. You know, we really appreciated you guys being here. And thank you very much, Dankeschön, and see you next time, I hope. Thank you.